So this is the Magic of Materials video for Physics 1202Q. And this is the ins and outs of the capacitor by Noah Freeman and Kevin Bates. So just to start real quick, the capacitor is a device that stores electric charge temporarily. And the very first capacitor was deemed the Leyden jar, which was invented in Holland in 1746 by a man named Peter van Musschenbroek, who's on the right-hand side here, and the Leyden jar is in the middle. So not much was known about the Leyden jar as many other early electrical devices, but it did allow scientists to use this as a platform and to do a greater variety of different electrical experiments. So for instance, Benjamin Franklin used the Leyden jar to store electricity from the lightning from the sky, obviously, in his famous kite flying experiment almost 300 years ago. So the Leyden jar was a glass jar which had metal foil on the inside and outside, so it was wrapped in metal foil, and the inner foil was connected to some source of electricity while the outer foil was connected to the ground. And as mentioned, although it was not understood how it worked at the time, scientists did discover that the Leyden jar stored some sort of electric charge even when disconnected from a power source such as a generator. So just moving quickly into how a capacitor works, you have a plate on the capacitor that essentially attaches to the negative terminal of the battery, shown in green, which accepts electrons that the battery is producing. And you also have a plate on the capacitor that attaches to the positive terminal, shown in yellow, of the battery, which also loses electrons to the battery. And once it is charged, the capacitor has the same voltage as the battery. So when talking about a small capacitor, the capacity is small, but larger capacitors can hold quite a bit more charge. So now we're adding a light bulb to the mix. So what you'll notice in this case is that when you connect the battery and you also have a light bulb, and the capacitor is pretty big, the light bulb will light up as current flows from the battery to the capacitor in order to charge it up. And once the capacitor reaches its capacity, the bulb is going to get progressively dimmer and eventually stop lighting up. So if you remove the battery and replace it with, say, a wire, then current will flow from one plate of the capacitor to the other plate of the capacitor. Unfortunately, we were unable to find a scanning electron microscope picture of a regular capacitor. They just don't exist. However, we have found an SEM picture of a interdigited capacitor structure, which was published in an article titled Dielectric Tunability of Thin Films in the Terahertz Range. So just going over real quick about how a capacitor is made. So in brown, you see we have two metal plates, and in between the two metal plates, you have an insulating material called the dielectric. The dielectric can be made out of all sorts of different insulating materials, such as plastic, glass, rubber, anything that essentially impedes current flow. And the brown metal plates are made of a more conductive materials, such as tantalum, aluminum, and silver. And in this video, we're now going to focus on silver. So obviously silver is used in jewelry, but it's also used in things like mirrors and silver tableware. And it was first extracted in the 4th millennium BC in what is modern-day Sardinia, off the coast of Italy. And typically silver is extracted from copper-containing ores, and when it is extracted this way, an electrolytic refining process is utilized. And silver is used in unconventional items such as bandages, ointment, and different creams. And we also found it interesting that hospital tap water has been tested with a silver layer membrane in order to purify and filter the water. And obviously, silver has a very large intrinsic value, which has made it popular as an affordable investment for millions across the world today. And here's our set of references, and we would like to thank you for watching our movie.